Assalamu alaikum. This is a continuation of chapter 8. The first part we did explain the control statement in regard to the if statement or testing or conditional statement. In this video I would like to explain the iterative statements or the looping statements, which is a repeated execution of a statement or statements for compound statement, which can be accomplished through iteration or recursion. There is some design issues regarding the control statement, regarding how the iteration is controlled and where in the loop the control mechanism should be stated. A counting iterative statement has many different parts, in which we can say that the loop can contain the looping variable, and also it should contain means for specifying the initial value, the start value of the loop, and the terminal, which is the last value of the loop, the sentinel, we call it the sentinel value, or the value that terminates the loop, because we shouldn't leave the loop to execute indefinitely. There should be something to stop it at some time. And also one of the statement should be the step size value, which is by how much the loop increments or decrements. It should be an integer, of course, because or it could be a floating point, because the loop can actually increments or decrements by a whole number or by fractions. Some design issues regarding this counter control loops that can be specified or listed as follows. What are the type and the scope of the loop variable? So what is the data type and what is the scope of the variable? Because there must be many functions in the program. There must be global variables, local variables, some built-in functions, and the variable can be specified and defined in any one of these locations. Should it be legal for the loop variable or loop parameters to be changed in the loop body? And if so, does the change affect the loop control? This is regarding the loop variable or the parameters, if it is sent as a parameter from one function to another, whether it is okay, it is feasible, it is correct syntactically and logically, that it should be changed inside the body of the loop, or how much it does affect that control structure. Also, should the loop parameters be evaluated only once or once for every iteration? These parameters of the loop, how many times should be evaluated? These are questions that also can be specified in the design. What is the value of the loop variable after the loop termination? So the last value of the loop variable, whether it was incrementing or decrementing, what is the last value after the loop stops? These are all design issues that can be specified for this kind of structure. Some examples can be shown like this. In the C-based languages like C, C++, C#, the control counter loop, which is a for loop, we call it for loop, has three different parameters inside the for statement, which is expression 1, expression 2, and expression 3. But the expression 1 is the initial value, the expression 2 is the loop control statement, and the expression 3 is the increment or decrement. Then the statement, which should be executed, controlled by this loop control value. So the expression can be whole statement. The whole statement can be the expression, or even the set mistake was separated by these commas. Sometimes you find them only two statements in case the control structure is Boolean. The value of the multiple statement expression is the value of the last statement in the expression. So if there is multiple expressions, the value of the multiple statement expression that will actually make up the value of the last expression of the last statement in the expression controlled by the loop. So if the second expression is absent, then this is an infinite loop. I mean, if there is no control here, this second expression we call it. If there is no second expression, if the control expression is not there, then there will be initial value and increment, for example, or initial value and decrement, and that means it is an infinite loop. A loop will not stop, because what makes the loop stops is this statement here. The design choices, of course, there is no explicit loop variable, all implicitly specified, and everything can be changed in the loop because of the iterative nature of the loop. So everything can be changed in the loop. Everything can be changed during execution. The first expression is evaluated once, but the other two statements are evaluated with each iteration. That means the first statement is evaluated once. That means the beginning of the loop. For example, for integer I equal 1, that's it, evaluated once. But these two will be evaluated in every single iteration. Why? Because if, for example, the statement says say this for int I equal 1, I less than or equal to 10, and I plus plus, let us just say we did this example. So the first one is evaluated once. It's gonna actually start from 1. But this one, for every iteration, that will check to see if the value reaches 10 yet or not, so that it stops the loop. So for every single iteration, this will be evaluated. And also this one, for every iteration, will be evaluated, because the first one is going to add 1 to the initial value, and then it's going to add 2 to the initial value, and then it's going to add 3, and then 4, and then 5, and then 6, until it reaches this. So these two are evaluated in every single iteration, but this one evaluated just one time. Also, one of the design issues or choices that it is it legal to branch into the body of the loop in C? Yes, it is legal to branch into the body of the loop in C. That means you can actually use a statement like goto to skip away from the continuous iteration of the loop, and that will be called conditional loop. That means it actually executes until it reaches a specific test or if statement, then it will skip. There is a lot of different branching. You can use goto, we can use continue, or can use break statement, as we will explain later in this chapter. C++ differ from C in two ways. They say the control expression can also be Boolean. Like you can say Boolean expression. Like if you say while true, that means while this statement is true. So this statement here inside the two braces will be executed. This statement, let me call it st1, statement 1, and then here st2. So in this program, for example, if while true, that means if this condition is true, then execute this statement. Otherwise, execute this statement. So we can say that the control expression here is Boolean. There is no any comparison that is done for this expression. And the initial expression can include variable type. That means variable type, like in this example here, you can include variable type. The variable type can be inside here, or could be declared outside and then used within that loop. And if it is declared outside, it's going to be global to every for loop expression that is contained or included in this program. But if it is just declared outside here, then it cannot be used for other different programs, and it is only going to be local for this loop expression. In Python, for example, this example here for loop variable in object, loop body, else clause. This is the else clause here. That the object here, this object in Python could be a range of numbers, or like this, for example, contained within brackets, bracket and bracket, and then like 2, 4, 6, or for example 1, 2, 3, 4, 5. It could be like that between brackets, or it could be a call to a range function, like here, for example. If you can put this function as function called range between two parentheses, where you have number like 5, for example, this will retain the values 0, 1, 2, 3, 4, which is there are 5 values starting from 0, like arrays. So the object here, that means it's going to loop from the loop variable in until this object, until the last value specified in this object as a range. And the loop variable takes on the value specified in the given range, one for each iteration. That means it's going to actually check it like incrementing iteration from 0, 1, 2, 3, 4. Loop termination. At the loop termination, the loop variable has the last value that was assigned to it. So the last value assigned to this object is going to be executed as the last statement executed in this loop before the loop terminates. And the else clause, which is optional, is executed if the loop terminates normally. So if the loop terminates normally, then the else clause is going to be executed. In other words, this loop is going to be executed if this whole statement happen to be true. Otherwise, after the loop terminates legally and normally, then the else clause is executed, or it is terminate, or it is evaluated. But in cases like there is an infinite loop, or the loop has some sort of branching, then the else clause will not be executed. So the program can terminate in some type of an error, or runtime error, or I would say a logical error. Repetition control is based on a Boolean expression, because we can have pre-test or post-test as in C and C++ and Java. So you can actually have them in separate statements, or you can have them in individual statements as block of statements. So we have the pre-test, which we can actually use as we will see here in the next slide here. In C and C++, we have both pre-test and post-test forms in which the control expression can be arithmetic. So the first one here, we call it pre-test. So the while statement is executed here, and the loop body is found after the while statement. But in the post-test, while you have the do-while statement, the body of the loop is executed, and then the test expression in the while statement is at the end of the loop. And there is differences between them. The most important difference is that in a while statement, in a pre-test statement, if the condition or the loop, if the condition in the loop or the controlled structure in the loop is false first time, the loop will not be executed at all. But in the post-test expression, if the statement or the while statement is false, then because the test is going to be done at the end, then the body of the loop is executed at least once. So the do will execute this loop body, and then it will test to see if this condition is true or false. If it is false, then it will execute. If it is false, then it will exit. But the body of the loop has been executed at least one time. So in both C and C++, it is legal to also branch into the body of a logically controlled loop. The branching can be through, for example, goto statement. Goto is a non-structural statement that can branch away from the loop. It is legal to use it, but it is not recommended, and it is considered one of the non-structured programming constructs, statements, to branch from the loop, because nowadays programs are written in what we call using constructs, using programming constructs, and it's structured programming, which there is no branching of the loop, and the loop will be executed within that block, and then if it exits or it jumps out of the loop, then it will find the next executable statement, and then if it is that statement is the loop itself, then it will actually go into the loop, execute that loop, and then finishes that loop and go to the next executable statement, and so on. Instead of using goto or break or continue, sometimes, although these three statements, goto or break or continue, are legal, and sometimes they are important, but it is not advisable to use them in programming. So in the user control mechanism, sometimes it is convenient for programmers to decide location for the loop control, to start from the top or from the bottom. Then, as I told you, there is sometimes you can use the design for single loops. You can use break or conditional. We call it conditional break, especially in the nested loop. So the design issues is should the conditional be part of the exit? Can this loop statement be part of the exit function, or should control be transferable out of more than one loop? This control structure, does it affect more than one loop, or just affect that specific type of loop? So these design issues for the nested loop, because a nested loop is a loop inside another loop, and each one of them, the outer loop or the inner loop, should have its own control structure or control statement. So the control statement will affect that specific loop, whether it is outer loop or inner loop. So the design issue here, should this control be transferable out of more than one loop to another, or each loop has to have its own control structure? In C, C++, Python, Ruby, and C#, they have unconditional exit, which is break. In Java and Perl, have unconditional label exit, break in Java, and called last in Perl, for example. In C, C++, and Python have unlabeled control statements called continue, that skips the remainder of the current iteration, but does not exit the loop at all, while break will exit the loop. In Java and Perl, they have labeled version of continue. I have created a program here in C++ to show you that the difference between these, at least between break and continue, and have the loop execute. This one is a small program, show that I would like to execute numbers. I would display numbers from 1 to 10, like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, when using break statement, you can actually use break statement conditional break. So if I reach 6, break. So if it reaches 6, it will break. That means it will actually display only the first 5 numbers, because it will exit the loop, but it does not exit the program. And the proof is that this one will jump from here and go to the next executable statement, which is the cout statement, to display these numbers here, 1 2 3 4 5, as you can see here. And if you actually if you change this one and make it continue, what happens is that this one will exit the loop, will only execute this statement, will skip over the number that is specified in the conditional test, but it will not stop the loop. In the previous program that we have, this program that we have, in which we have seen this 1 2 3 4 5, we have break statement which is exits the loop 1 2 3 4 5, exit the loop and then get to this statement, return 0, to stop the program. But in this program, I replaced break with continue. Let me just compile it again and show you what happens. What happens is it skips over that number only 6. So 1 2 3 4 5, then it skips 6, it goes to 7 8 9 10, which is as I mentioned here, that in the break statement will stops the loop and continue, skips the remainder of the it skips that current iteration, only that current iteration, but does not exit the loop. It will allow for more iteration for the loop until the loop finishes by that first control structure, which is I less than or equal to 10. Iteration based on data structures. So here the number of elements in data structure control loop iteration, and the control mechanism is called iterator, and it is controlled by what is called a function as iterator that iterates or increments, usually increments or decrement that loop. So a user-defined iterator can be built separately and used here with a parameter, like in that range. For example, in this for loop statement example, this one, it's actually going to execute the loop until that parameter p in this traverse function has been executed. So what's the value that that terminates this loop? The value that terminates loop is specified in the function traverse according to the value specified in the parameter, which is p. So you can build a user-defined iterator and then have that iterator be specified in the parameter value. In PHP, we have current, next, and reset. The current points at one element of the array. The next moves the current to the next element. Next, that means like moving to the next element of like in the array. And reset, this one will actually move the current to the first. Will actually like swapping values. Swapping the values. To reset means put the first number second, make it first, and number third, make it second, and so on, like reordering. In Java 5, it uses for. Sometimes it is called for each in some programs in Java, like for arrays. So the iterative interface can be a string, and then here can be terminated by also a list in the array. So the control structure will be actually from the element that is specified in the string to my list, which is whatever list that has been specified in the structure of this array list. Here is whatever statement that can be executed based on this loop statement. In Ruby, blocks are attached methods. They can have parameters in vertical bars like this. So parameters can actually stay in bars, vertical bars. In this example, for example, they use def keyword, and here they specified the last, define the last part, and then specify also like initialize the first and second variables and give them these variables separated with commas, such that one for the first and one for the second. So here when you say while first less than last, whatever last value is, yield first. That means execute first or display first. Then you can actually increment by assigning the two variables to the second first plus second. Here you can add first plus second, which is 1 plus 1, and keep the loop going on until you end. This one is to end the while statement, and this one to end that program, which is starting here with the definition for this program. So in Ruby, this for statement can be specified with a yield statement. That yield means if the while statement evaluated to true, then the yield statement is executed. Otherwise, it will exit the loop. For unconditional branching, it transfers execution to the specified place in the program. So unconditional branching, that means you actually use a statement like go to skip over the specified location in your program. Also, some languages do not support go to statement, like Java for example, but C and C# and C++, they support using go to statement. You can use go to in a switch statement, or you can use it in the loop, especially if you have like a program using a switch statement where you would like to, in the default, you can use in the default section, in the default part, you can use go to, so that if the value is not provided, you start entering numbers again. Also, you can use it in instead of break in the loop, you can use go to actually allow for more iteration instead of the loop breaks. Guarded commands. In this guarded commands, the purpose of this guarded commands, this is support new programming methodology, which is supported, which is actually provided for correctness during development. There is two linguistic mechanisms for this guarded commands in CSP. So what is the basic idea? The basic idea, if the order of evaluation is not important, the program should not specify one. So if the order of evaluation is unconditional, it is not important, then the program should start from top down without using any without using what we call branching, whether conditional branching or unconditional branching. So that means there is no go to, there is no break, there is no continue, there is no exit, and the program continues normally. In the select guarded commands in select statement like this, for example, if a statement is executed multiple times, if the Boolean expression is true, execute this statement. If the Boolean expression is true, execute this statement. And then use multiple ifs, as many ifs as you want. But the last one has to end with phi. phi, which is reverse of if, and you put f here and I here. Also, they use it if you are using case in a switch. They're using case like case 1, case 2, case 3, and then in the end use ISAC, which is case backwards. Here phi is if backwards, ISAC is case backwards. All are used in some guarded command. So what is the purpose? The purpose is to actually allow for iteration of all cases, whether conditional statements or case statements. This kind of a structure is basically seen in the selection structure, like case or if statement. So you evaluate all Boolean expression. Evaluate this one and this one and this one and this one, and the last one. Evaluate them. Also in the cases, you evaluate all the cases. Case 1, case 2, case 3, case n, until you finish with the word ISAC. So if more than one are true, they choose one deterministically. That means if there is more than one, you can actually specify them. We can use AND also, or logical operator. But if none of them is true, then there is a runtime error will happen, because one of them should be evaluated to true. Also in the loop, we can use also do loop or while loop. But in the do loop, you can have do and then and then the statement, the loop statement, and then the statement that should be executed after the loop, and then again do the loop statement and then the statement after the loop, and so on. Same like you end this program with phi and ISAC, you end do with odd, which is the loop. This is the loop guarded command. So in this case, also you evaluate all Boolean expression. Also, if more than one expression is true, you choose also one that determine the exit of the loop. Because if none of them is true, this just simply the loop will exit. It will not give you an error. The rationale behind guarded command is that connection between control statement and program verification is intimate. That is, you can actually avoid using this non-construct like go to statement and so forth. And it is actually to use it logically with pretest loops as well. And we call it the verification is very simple with guarded commands, because in guarded commands you have a guarantee that all commands are executed, all evaluations. I mean all testing control structure, whether in selection or iteration, are executed and evaluated, and then executed, and then terminated normally. And this is a summary of this last part of this chapter, and I would like to upload this chapter also as well to review it at your own pace. All right, thank you so much.